Hey, this is Miss D, and these are the notes on projectile motion. And so we're going to basically cover just a quick definition of what projectile motion is and then the two types of problems that you're going to see in this unit. So the first thing you need to know is that a projectile or projectile motion is just something that's moving in two dimensions at the same time. So projectile motion is two-dimensional motion. So it's going to have a horizontal component, which we'll refer to as the x component, and that's going to be like the same as like a ball rolling across a table. And then there's also going to be a vertical component. We refer to that as the y component, and that's the same as free-falling objects. So like if you drop a ball off of a cliff. So let's actually look at a cliff. Let's put Wile E. Coyote up on top of the cliff, and we're going to look at the different components there. So the distance from the top of the cliff until the ground is going to be the distance in the y direction, in the vertical direction. The distance that Wile E. Coyote will land from the base of the cliff, so where he smacks into the ground, that's going to be the distance in the x direction. Then we also have the velocity in the x direction. That's how fast he's traveling in the horizontal direction, and how fast he's traveling in the vertical direction would be the velocity in the y. Now we know that if Wile E. Coyote jumps off a cliff, he's going to accelerate towards the ground at a rate of 9.8 meters per second squared. And we know that the time that it will take him to hit the ground would be like the time until he hits the ground. That's time y. Now, if you think about it, if he hits the ground at time y, then he's hit the ground at time y. So that's going to be the same as time x. So time is time. Like Wile E. Coyote hits the ground in the x and the y direction at the same time. So the time up and down is the same as the time across. So the vertical and the horizontal time number is always going to be the same. So we're going to actually look at a little practice. So if Wile E. Coyote runs off a cliff that's 100 meters high at 3 meters per second east, so I'm running towards the east, or he's running towards the east, then let's go ahead and solve for most of these things. So first of all, we're going to start with, on a cliff problem, we start with the vertical component. So we're going to start with the y component. So let's go ahead and fill in what we know. We know that he's going to travel 100 meters from the top of the cliff to the ground. When he leaves the cliff, his initial velocity is 0. We don't know his final velocity, but we do know his acceleration is 9.8 meters per second squared. So I'm going to use this formula. D in the y direction is 1/2 at squared, which is just the d equals 1/2 at squared, and I'm just talking specifically about vertical components right now. So let's plug in. That's going to be 100 equals 1/2 9.8 times t squared, and I'm just going to solve that for t. So if we do that, t is going to equal 4.5 seconds. So I'm going to go ahead and fill that in, 4.5 seconds. Now I said that my time in the y direction was the same as my time in the x direction. So vertical and horizontal time are both going to be 4.5 seconds. So now I have my time, 4.5 seconds, and I know that the the horizontal velocity, the speed that Wile E. Coyote runs off the cliff, is 3 meters per second. So that's not going to change. If we ignore air resistance, he's going to be going 3 meters per second in the x direction the entire time. So I can use this formula, V equals d divided by t, and I can go ahead and plug in. I know that my time is 4.5. Actually, hang on. I plugged that in wrong. So we need to go ahead and we need to do that like this. I need to do 3 times 4.5 equals d. And so 3 times 4.5 equals 13.5 meters. So that's going to be that. And let's go ahead and let's look at the rules. So the first thing we want to do is we always want to break a projectile problem into the x and the y components. And let's look at the steps for solving And this will be for any of the cliff type problems that you're going to encounter. Anytime you're dropping anything from a height and it's being affected by gravity, you're always going to start with finding time. So that's the most important thing. If they give you time, then you're going to have to look for something else, generally the height in the y direction, but you're always going to make sure that you have the time. After you do that, you need to know that the only force acting on a projectile is gravity. So if I have an object that's being dropped, the only thing acting on it's gravity. Remember, gravity on Earth is 9.8 meters per second squared. And then you need to know that the velocity in the x direction does not change. It's going to be constant. So like in the previous problem, Wile E. Coyote left the cliff at 3 meters per second in the horizontal direction, 3 meters per second east. So when he hit the ground, he was going 3 meters per second east still. He was going much faster than that towards the ground, but his x component stayed the same. So here are the formulas that you're going to need to use. V equals d divided by t, but it's Vx equals d divided by t. That should look familiar to you. And then dy equals 1/2 at squared, where dy is just the distance that you're traveling in the vertical direction. And that should also look really familiar. Remember, acceleration equals 9.8 meters per second squared. So, but what if we have something that, that is moving in 2 dimensions, but it's not falling? So I have something that's not falling. So let me give you an example. Let's say I have a river, and that river is moving at a rate of 5 meters per second to the east. And on that river there's a boat. And the boat is traveling from the north bank to the south bank at a rate of 2 meters per second. So the boat is moving south at 2 meters per second, but then the river is carrying it downstream at 5 meters per second. And we'll say that the stream is 200 meters across. So if you look, the boat is going to be carried across by its own velocity and then downstream by the river. So we're going to look at that green arrow. That's going to be basically where the boat ends up. So how far downstream does the boat travel? And the way I'm going to solve that is I'm going to go ahead and I'm going to find the y components and I'm going to find the x components. So to find the y components, I need to know my velocity. My velocity in the y direction is 2 meters per second. The distance is 200. So I'm just going to do v equals d divided by t. You can use a triangle to figure out that t is going to equal d divided by v. So that's 200 divided by 2. My time is going to be 100 seconds. Then I'm going to take that same time and I'm going to plug it in for the x. So on the x side, I know that my boat is traveling at 5 meters per second to the east, and I know that time is 100 seconds. And I'm going to use the same formula for the x component. Velocity in the x direction is the distance x divided by time. So I'm going to plug in, use the triangle. I'm going to have d equals velocity times time. And that's going to give me my distance. That's going to be 5 times 100. So my distance is 500 meters to the east. So the steps for finding what we call a riverboat problem, the first thing that you need to do on a riverboat problem is you need to find the time. So again, we're finding the time. Then after you find the time, you're going to keep your velocity for x and your velocity for y separate, and you're going to keep your distance for x and your distance for y separate. So basically, same thing, you're just keeping the x components in one set of equations and the y components in the other set of equations. I know it sounds really complicated, but it's really not. If you need any help, just come ask.